Greetings, judges. I am Aarna Gupta, a student currently in the 10th grade, here to present my innovation for the Raman Awards Round 2. My project is based largely off of the principle of pressure gradient force, which is the natural tendency of fluids, like air, to move from a region of high pressure to a region of low pressure. Now, since in the regions of high pressure, there is a larger amount of air molecules being packed into a given space, this causes a larger force to be exerted. Whereas in the region of low pressure, there is a lesser amount of air molecules being packed at a given space, which causes a lesser amount of force to be exerted. Now here, pressure gradient force acts as an unbalanced force which pushes these molecules from the crowded high pressure area into the less crowded low pressure area. Now this process continues until the system has been equalized. Now, today, I'm going to present two things. Number one, an innovation of mine which is based off of this principle. And secondly, two experiments to actually understand the concept at hand. Let us begin with the innovation first. Here, I have my asteroid mining probe NOVA, which I've been engineering for over a year now. Now, in short, what will happen is that NOVA will be deployed inside a rocket. It will land on an asteroid, stabilize itself, and as soon as it stabilizes itself, it will start drilling. Now, after drilling for about 15 minutes or so, it will stop. And this is where the fun actually begins. As you can see, the drill has been divided into two chambers. Yellow for high pressure and blue for low pressure. Now what will happen is that after it stops drilling, high pressure gas would be released inside the high pressure chamber and low pressure gas would be released inside the low pressure chamber. Since there is no considerable gravity acting on the displaced materials that have been displaced by a drill, what will happen is that as soon as we lift the separation in order to allow the gas to move from the to actually move from high pressure to low pressure, these materials would move along with the gas inside the low pressure chamber and get stored up in the storage module. Now this would, one, help us save the cost of a more complicated mechanism, and two, help us save weight which is actually on board the craft itself. So for our first experiment, we will observe the Bernoulli's principle using two balloons and a string. So when we blow between these balloons, one would naturally expect them to move further apart. However, that's not the case. Let's observe. When we blow between these balloons, we observe that they move closer to each other. Now this is because initially, before we blow into the balloons, the air around them is relatively static and the atmospheric pressure is being applied uniformly on all the sides. However, when we blow between the balloons, we create a stream of fast moving air. Now according to Bernoulli's principle, an increase in air velocity actually leads to a decrease in air pressure. So what this means is that the air pressure on the outer sides of the balloons is now higher than the air pressure between the balloons. Now this higher external pressure causes these balloons to move inwards, which causes them to move together. This is the same principle behind how airplanes can lift up. Thank you. So for our second experiment, we need a plate full of water, a tea light candle, a wine glass, and a box of matchsticks. The first step is to light our tea light candle, wait for it to burn for a few seconds, take our wine glass and cover it. Now, as we observe, the water slowly moves up the wine glass, right? The aim of this experiment is to show the tendency of fluids to move from a region of high pressure to low pressure. As you can see, the water moves up the wine glass. Now, why is this actually happening? So what happens is, the candle inside the glass heats up the air that is being trapped inside the glass, right? Now, this air actually, after the candle extinguishes, this air cools down and contracts rapidly. This causes an area of low pressure to be created inside the glass. Now, since our atmosphere has a higher pressure compared to that of inside the glass, what happens is that the atmospheric pressure, which is higher than that inside of the glass, causes air, pushes the fluid inside, pushes the water actually to move inside of the glass, right? Forcing the water inside the low pressure chamber.